Solving triangles with bearings. Consider the following scenario. You and your friend get separated in the woods. Your cell phone app tells you that your friend's bearing is 270 degrees from you, and the distance between you and your friend is 200 meters. Can you draw a picture describing your location and the location of your friend? Please take a moment to pause this video to try to draw this picture, and when you're finished, unpause it. There are probably two scenarios that could have occurred when you drew your diagram. Some of you could have imagined something like this, whereas others could have imagined something like this. Which one is correct and why? Well, in order to draw the correct picture describing your location and the location of your friend, we first need to understand what bearing means. A bearing is the angle in degrees measured clockwise from north. Bearings are usually written using 3 digits. For example, 20 degrees clockwise from north is usually written as 020 degrees. Now this is very different from what we are used to using in the polar and rectangular coordinate planes. We're used to starting off on the positive x-axis, or the east direction, when measuring 0, and then we end up moving counterclockwise when we're talking degrees or radians in that respect. Now, when we measure bearings, we're beginning in the cardinal direction of north. In other words, on the positive y-axis when we measure 0 degrees. And from there, all of the extra degrees are moving in a clockwise manner. So far, when asked questions about bearings, we've been given diagrams to help us. What would happen if a diagram wasn't provided for a problem? How would we get started? Let's look at an example. In triangle ABC, the bearing of A from B is 235 degrees, and the length of AB is 10 meters. The bearing of C from B is 150 degrees. The bearing of A from C is 270 degrees. Calculate the length of segments AC and BC, as well as the measurement of angle BAC. Let's try breaking this word problem down one sentence at a time in order to determine the calculations that we need to make. So let's start by drawing any triangle ABC. Now let's look at the given information in the first sentence. In triangle ABC, the bearing of A from B is 235 degrees and AB is 10 meters. So we were given that information, so we drew it in and labeled them. Now let's look at the second sentence. The bearing of C from B is 150 degrees. So that means that from B to C, this angle measurement here is that 150 degrees, so we labeled it. Can we now figure out the measurement of angle ABC? In other words, the smaller angle right here? Take a moment, pause the video to calculate your answer, and when you unpause it, the solution will be given. Well, because we found out the bearing of A from B was 235 degrees, and the bearing of C from B is 150, we can conclude that this smaller angle measurement is found by calculating the difference between 235 and 150. So when we do that, we end up getting 85 degrees. That is the measurement of angle ABC. The third sentence of our problem states that the bearing of A from C is 270 degrees. Let's actually draw it in and label it. So from the north direction, we have a bearing of 270 degrees, which is labeled. And now the question is, can I figure out these two smaller angle measurements that are given here. For example, this one inside the triangle and this other one outside of the triangle. Take a moment to think about it. The hint is think about geometry. And when you're done thinking about it, you can unpause the video to reveal the answer. If we actually extend segment BC in this direction and use the north direction as parallel lines, we have a pair of corresponding angles here. They're labeled as theta. And they have a measurement of 180 minus 150, which is 30 degrees. So these are both 30. You could have looked at the fact that these two are corresponding angles, or you could have also noticed that 150 degrees and 30 degrees are same side interior angles, which are supplementary, and subtracted 150 from 180 in that manner. Therefore, the measurement of angle BCA will have to be 60 because we know this is 270. So the sum of these two smaller angles would have to be 90 to get us up to 360. And we already know this is 30. So if I take 90 and subtract 30, I get 60. Now can we calculate the length of AC, the length of BC, and the measurement of angle BAC? We can calculate these measurements, starting with the measurement of angle BAC. Since we already know that angle ABC is 85 degrees and we know that BCA is 60 degrees, we know that the sum of the angles in a triangle is 180, so we can subtract these two smaller angles from 180 and get 35 degrees, which is the measurement of angle BAC. Now that we have the measurement of all three angles and one side length, how do we determine the lengths of the other two sides? Because we're given all of the angles and one side length, we need to use the law of sines in order to determine the lengths of the other two sides. Let's start with AC. We know that angle BCA is 60 degrees, and we know that the side opposite it is 10 meters. So we can do sine of 60 over 10 equals sine of 85 over AC. And then if we cross multiply, we get AC times the sine of 60 is equal to 10 times the sine of 85. And then if we divide both sides by sine of 60, we end up getting that AC is equal to 10 times the sine of 85 degrees divided by the sine of 60 degrees. And we substitute these values into a calculator. 10 times the sine of 85 divided by sine of 60, which equals 11.503 meters. Now let's calculate the length of BC. So again, we know that angle BCA is 60 degrees, and we know the side opposite it is 10 meters. So we have sine of 60 over 10 is equal to the sine of 35 degrees over BC. If we cross multiply, we get BC times the sine of 60 is equal to 10 times the sine of 35. And if we divide both sides by sine of 60, let's calculate it. And we get 10 sine of 35. Remember to close the parenthesis here, because if you don't, it's going to evaluate more than just the sine of 35, divided by sine of 60. Again, close parenthesis, and we get 6.623 meters. Here's another example. In triangle DEF, the bearing of D from E is 252 degrees. The bearing of F from E is 133 degrees. DE is 12 meters, and the length of EF is 10 meters. Calculate the measurement of angle D, the measurement of angle F, and the length of DF. Let's start by drawing our picture. So we are given a triangle DEF, and we are told that the bearing of D from E, so I'm going to draw the north direction here, is 252 degrees. And the bearing of F from E is 133 degrees. So that's this extra, or the smaller angle right here, that's 133 degrees. We can use both of these bearings to determine the measurement of angle DEF. So if I do 252 and I subtract 133, I end up getting 119 degrees for the measurement of angle E. We're also told that DE is 12 meters and EF is 10 meters. What we have to calculate is the measurement of angle D over here, the measurement of angle F over here, and the length of DF. The diagram given verifies what we found on the last slide. We found that because the bearing of D from E was 252 degrees and the bearing of F from E was 133 degrees, the measurement of angle DEF is 119 degrees, and it's found by subtracting the two bearing values given to us. We also have labeled that DE is 12 meters and EF is 10 meters. And now we can try to calculate the measurement of angle D, the measurement of angle F, or the length of DF. Well, if we look at what we're given a side, an angle, and then a side, and we can find the side opposite the angle using the law of cosines in this situation. So let's set it up. So DF squared is equal to DE squared, which is 12, so 12 squared, plus EF, which has a measurement of 10, 10 squared, minus 2 times 12 times 10 times the cosine of 119. And then to find the length of DF, we're going to evaluate this and square root it. So let's rewrite it with the square root. So DF is equal to the square root of 12 squared, which is 144, plus 10 squared, which is 100, minus 2 times 12 times 10, which is 240, times the cosine of 119 degrees. And if we substitute this expression into a calculator, we're going to have 144 plus 100 minus 240, and then cosine of 119, close parenthesis for the cosine as well as the parenthesis that's in the square root, and that's going to equal 18.983 meters. And the work here basically verifies the solution that we found for the length of DF. It's 18.983 meters. So now we can use this information along with the law of sines to find the measurement of angle D and the measurement of angle F. Let's start with the measurement of angle D. So we have the sine of D over the side across from it is 10 is equal to the sine of E, which is 119, over 18.983. And then if I cross multiply and divide, I will have that the sine of D is equal to 10 sine of 119 divided by 18.983. And if we do the inverse sine of this fraction, we will end up getting the measurement of angle D. So it's 10 sine 119 divided by 18.983. And when we put these into our calculator, let's actually do that. We have to first do inverse sine of 10 times the sine of 119 divided by 18.983, close parenthesis, and we end up getting 27.435 degrees. And then to determine the measurement of angle F, we can subtract the sum of 119 and 27.435 from 180. And when we do that, we'll end up getting 180 minus 119 minus 27.435, which is 33.565 degrees. So measurement of angle F equals 180 minus 119 minus 27.435. So the measurement of angle F is equal to, again, 33.565 degrees. And here are the solutions that we found. It does show that we use law of sines to determine the measurement of angle D, which again was 27.435. And then you can either elect to use the law of sines again to get 33.565 using the work shown here, or you could use the triangle sum theorem and add up 27.435 and 119 and then subtract that value from 180. Either way, you will get the answer of 33.565 degrees for the measurement of angle F. Now let's talk about applications with bearings. The diagram shows two ports, A and B, and a buoy, C. The bearing of B from A is 250 degrees, and the length of AB is 350 kilometers. The bearing of C from A is 110 degrees, and the bearing of B from C is 265 degrees. Calculate the measurement of angle A, the measurement of angle B, and the measurement of angle C. Then use the law of sines to calculate the length of BC, and use the law of cosines to calculate the length of AC. Let's start off with part A. At the very beginning of this problem, we are told that the bearing of B from A is 250 degrees, so that's labeled in blue. And we're also told in the problem that the bearing of C from A is 110 degrees, also shown in the problem. We can use these two values to calculate the measurement of angle A in our triangle, or the measurement of angle BAC. If we take the difference of 250 and 110, we get the measurement of angle A to be 140 degrees. We are also told in this problem that the bearing of B from C is 265 degrees. So that's also been drawn in the diagram. We know that the north arrows are parallel to one another, and using that piece of information, we can determine that the measurement of this angle theta is going to be 180 degrees minus 110, which is 70, because we have same side interior angles, and they are supplementary. So therefore, to find the measurement of angle ACB, I can take 360 and subtract 265 and 70 from it to get its measurement, which is 25 degrees. And then since all of the angles in a triangle sum to 180, we can subtract 140 and 25 from 180 to get the measurement of angle B, which is 15 degrees. Now that we've found the measurements of all of the angles in the triangle, let's calculate the length of BC using the law of sines. BC is across from 140, so we're going to do the sine of 140 over BC is equal to the sine of 25 over 350. And when we cross multiply and divide, we get that BC is equal to 350 times the sine of 140 divided by the sine of 25. If we substitute these values into our calculator, 350 sine of 140, close the parenthesis, divided by sine of 25, we end up getting 532.3377. The fourth 7 rounds the third value of 7 up to an 8. So we get 532.338 kilometers for BC. Now let's use the law of cosines to calculate the length of AC. Well, AC is here. It is across from angle B. And by the law of cosines, we need to use the sides that are used to create the angle that we're using. So we're going to be using 350 and 532.338 in our formula. So we have that AC squared is equal to 350 squared plus 532.338 squared minus 2 times 350 times 532.338 times the cosine of 15. If we evaluate these, we end up getting 405,883.746 minus 372,636.6 times the cosine of 15. And if we square root that expression, we will get the length of AC. And when we do put that into a calculator, so we're doing square root, we want to do the square root of 405,883.746 minus 372,636.6 cosine of 15, close parenthesis, equals 214.3465. The 5 rounds that 6 up to a 7. So we do end up getting that AC is equal to 214.347 kilometers.